Infrared spectroscopy. I'm not going to go too far into the details of this because I have a lot to learn about it. But for my readers who are already aware of the general theory of stellar metamorphosis, you have your basic Hertzsprung-Russell diagram. The young hot stars are up here. They cool, shrink, and die. And eventually, they have no visible spectrum. Visible spectrum. Okay? It stops right here, like where the M stars are, or the the brown dwarfs. Okay? And then, my listeners already know this, the graph continues until eventually it gets to be a rocky, dead world. Okay? Somewhere down here, like Mercury. For infrared spectroscopy, it's majorly used in chemistry to determine the chemical compounds of the pieces that they're measuring, okay? Now, being that astronomers, they don't like chemistry. To hell with chemistry. Which means, what we can do here is actually classify stars that are mostly radiating in the infrared and give them classifications based off of what their spectrum is in the infrared spectrum. Which means they're going to be like down in this area right here, right around here. Alright, I'm going to go ahead and erase this and then draw it over again. Now, one of my listeners, he told me that, there's probably like 10 different extra classifications after the visible spectrum classification. So here's the bottom of that graph. The visible was up here. And then you had the infrared. It starts coming down. And the star cools and dies. What I'm wondering is, how would we classify these objects as they cool and die? And what chemicals can we expect to find as we move along this little diagram here based off of the infrared spectrum? Will we find a lot of methane? Will we find a lot of water? Should we find a lot more, I don't know, hydrogen, different kinds of hydrogen chemicals, molecules? Now, I'm saying this because they have the visible spectrum all figured out. They're O, B, what's the next one? O, B, well, you get the point. Those are the classifications for the visible stars. What are we going to classify the infrared stars at? The stars that don't have visible spectrums. We had to use the WISE telescope to find. What chemicals would differentiate them? Okay? How hot would separate? What would the temperature be? How hot would the star need to be? Okay? Now, this is important as well because the heat and the chemicals involved would also be important because some chemicals, such as hydrogen gas, which is what? H2, it's a diatomic molecule, have a very high specific heat capacity, which means they can store a lot of heat. So if you have a star, say like right here, and then most of its hydrogen is in the outer layer as H2 gas, they can store a lot of heat in the outer layers. So you can just heat that up, and that gas won't go anywhere. It will just protect the inner layers from heating up any further. But as well, if you have a star that has a lot of water, water has a high specific heat capacity, but not as much as H2 gas does, given it's a lot thicker up here. So you would have less of the ability to sustain start to hold heat before it, evaporates into interstellar space or whatever. So which means if it has a lot of H2 gas, it'll stay right here longer than a star would be that has a lot more water, or water vapor clouds. But this is theorizing based off of the understanding that these brown dwarfs, they're not failed stars. They're very old stars, which means they have to take all those elements that are in their ionized state, such as ionized hydrogen, ionized helium, ionized carbon, all that good stuff, and it combines these to make gas, and that's what begins the gas giant phase of star evolution. Now, I'm not too sure where I'm going with this per se. I just wanted people to start thinking creatively concerning this matter, because we have to start classifying these things now. Infrared spectroscopy is going to be very important in the future. We just started finding brown dwarfs like what? In the 90s or 80s or whatever? This just started. This is where we're going to bridge that gap between the visible part of star evolution to the infrared, and then it gets to the really hazy part, which we have to determine later. I'm not too sure what to do about all this stuff. I'm guessing we could actually just reverse engineer the Earth and work our way backwards from there, because by the time the star reaches here, a lot of the outer layers, they've been ripped away from orbiting different stars and having to deal with that stuff.